There we go. We've got everything working. Good morning, good evening, good afternoon to people around the world. This is Martin Hubel, your host of the DB2Night show, and we are up to show number Z136. It's a lot of DB2 education on the mainframe. Once again, we're very pleased to have as our special guest, Sheryl Larsen's back with us. How are you doing today, Sheryl?
Fabulous.
Wow, that's great. It doesn't get better than fabulous.
Mm-hmm.
Yeah. So let me get these the announcements out of the way as quickly as coherently possible, and we'll move on. Our show, the way to keep up on us, the easiest way is to follow hashtag Db2Night on Twitter. And I put up the announcements on shows a couple of days before to remind you, and I also put up when the replays are available on YouTube. We have that now that you don't have to download anything should you choose not to, although the handouts are always really useful, and you're welcome to grab that from our replay blog as always.
Mm-hmm.
There's our famous disclaimer. I'm not going to read that. I stopped reading that about 5 years ago.
Okay.
Everything, we respect people's copyrights, and the material is for people as they choose to use it, and we're recording it, and you can get replays and all of that good stuff. Everything belongs to DBI. And, other quick announcements. Our upcoming shows, we're winding up season 14 here on the DB2Night show. I've been doing I started on the Z side when Scott Hayes was with us, and when Scott Hayes left DBI, I took over both sides of it. Our last 4 shows of the year are in 2 weeks. We have Dale McInnes of IBM Toronto Lab, and I've got the dates wrong there. Let me fix that. I've got the 2 dates in a row there. They've got 2 people on the same day. It actually should be. Let me go back on that. I'll just fix that while I'm looking at it. That should be the 5th. Is that, and that makes it 2 weeks from now, I believe. Next week, I'm actually off at an IBM briefing, so I will not be around to do the night show. I'll be flying to Germany, of all places, which will be a lot of fun.
Nice.
Berlin lab. It'll be a good thing to see some good old friends and get some up-to-date information from IBM. So in 2 weeks, we have Dale McInnes on the new DB2 Always-On architecture they have. The week following that, just before IDUG, is on May 12th, is Dave Belke, who has achieved the status of lifetime IBM champion, just like me. And I'm glad to see Dave's in on that. And Dave's also an IBM Go consultant for just about as long as I have, or as long as I have, going back into the 1990s. In June, we have the machine learning optimizer in DB2 LUW with Callisto, and we also have Somia presenting on June 16th with the DB2 User Experience Transformation Strategy. IBM's been doing a presentation of that type for the last few years on System Z, and it's great to see it. And that'll finish season 14. As always, the founding sponsor of the DB2Night show is DBI Software, and we like to give them a mention on what they're up to. You can follow a video and watch that. They get a Starbucks gift card. And also the big news from DBI is they've taken their tools to the SQL Server platform as well.
Wow, that's impressive.
Yep, they've been working hard, those guys. Every time I talk to my friends there, they've got some really cool stuff they're working on. It's all about performance.
Mm-hmm.
Our winner last month is Uma Vami of AAA California. Congratulations, and the gift certificate that's likely already come your way. And again, our sponsors are DBI and yours truly, Martin Hubel Consulting. And with that, we're into our polls, and we have our little standard stuff that we like to ask people. We've updated this one today is because on the mainframe. Now we have DB2 13. I put a V in it simply because even though they take that out and put the V in from time to time in various places, it always seems to be a good thing to see. We actually have some 13s showing. That's really impressive. I'd like to see about 70% or so of the audience vote. We've got a few more opportunity to get things in terms of that, and we're up to that magic number, so we'll shut that off and share the responses. Looks like we got one person on version 13. Everyone else is on version 12. That's great to see.
That's great to see. Yeah.
This is an old question, but it never hurts to ask just to see what people are doing. How many years relational experience do you have? And one of the things we face with the Z audience is the number of people that have all sorts of years of experience, from 20 years plus, is a great majority of our audience, which is fantastic to see, but it's also an indication that you guys are probably like me. You're closer to retirement than you are to starting your career.
Yeah.
So here we are. And the next one is, when do you plan to move to DB2 version 13? And I've only given 3 answers at this point. I guess a fourth answer would have been, I don't know, but I guess we'll count that as later today.
Mm-hmm.
All right, there's we'll close that off and share that result. And 2024 looks like a sweet spot. Some people are going this year, and some people are undetermined or later on. So with that, that takes us through the polls that we're going to do, and I'll close that, and we will move on to Sheryl. There we are. I'll put your picture up there. We'll put you over here, and we'll make you the presenter. You answer yes to that question, we'll see your screen. And as always, Sheryl, I'll be monitoring the question tool. People have a chance to type in some questions into the question tool.
Okay.
I'll follow that.
Can you see my screen?
I can see your screen, and all you need to do is go into presentation.
All right.
So I will mute myself to eliminate any noise and dog barks on this end. And please take it away.
All right. Well, welcome everyone from wherever you are. And I'm going to concentrate on not talking too fast, because I know this gets downloaded for months and months after that I do deliver this. But I'm very excited to bring you examples of DB2 mistakes that I've come across over the years, so that you can avoid these types of mistakes. I now work for a company called Kyndryl, a little bit more about that. And I'm an actual sales rep for a particular one and only product called zCloud that no other managed service provider actually can offer. Let's see which button makes it go to the next slide. There we go. So a little bit about Kyndryl. It used to be part of IBM, and you might have known it as Global Services. It has a new name, Kin for kinship, and I can't remember what the drill part is, but we're all about the heart of progress. And here's some statistics about how huge they actually are. We have 400 mainframe clients. Think about this, 600 machines. Globally, 6.1 million MIPS. And there are, there are companies that are hitting that million MIP mark in our portfolio. It's pretty exciting. Think about the petabytes of storage, 5,000 LPARs, 28,000 subsystems, and the killer is this 100 million batch jobs a day. And who's maintaining that? Well, Kyndryl's, pretty large company, but the experts in the mainframe area, we're at 8,000. And the average age for this team, and they're spread around the world, is actually quite low because we have just a way of bringing people in at a young age and nurturing them into the mainframe environment. And they move on quite fast. We've got people, a whole bunch of them. Average age, for instance, in Brazil is like 36 years old, and they've got 10 years experience, and they're as good as the 30-year-old veterans that are on the market today. I can attest. We do onshoring, we do nearshoring, we do offshoring, and part of the product, this zCloud product, is basically, I describe it when I'm selling to a customer. The basic question is, do you really want to be part of managing your whole data center, or do you want to instead hand your keys over to me and let Kyndryl take care of everything, including disaster recovery? You won't have to worry about talking to another vendor. You won't have to worry about upgrading a single thing. And we are going to give you all the kinds of guarantees and also always put you on the latest and greatest technology. Where we are in the market, 6.1 million MIPS is more than all of our other competitors combined. Because we're that large, we see problems spread throughout the world, and when we find a problem in one area, we let everyone else know so that they don't have to come across that problem. So that's the gift of being large, is that we're the most on top of the technology out of all the service providers because of the state that we're in. A little bit about me. My first SQL class was a long time ago, DB2 version 1 beta. And I thought it was a pretty silly language. Select from where, group by having. And that's because I came from this world. This is assembler language. Shift left, double word, yeah, SLD. Rotate right, insert bit. All right, it looks, machine language. So I came from machine language, and that's why I thought SQL was kind of silly. But that was a long time ago. No internet, no cell phone, laptop, earbuds, email. Fast forward to now, and here's what happened to the SQL language in all those years. And so I got it kind of a trickle approach, and because it was trickled into my career, I've been constantly in a deep dive behind the scenes and what all these clauses actually do, how they behave, how they perform, how they optimized, and everything like that. So that's my claim to fame is people still across the country send me some SQLs and they say, can you help me fix this? And that's my favorite thing to do, for breakfast is fix people's queries. It's kind of like a puzzle for me, and figuring it out is just pure joy. So the lessons learned that you're going to see today: lack of powerful new and old SQL features, and then of course all the misuse. I've got a case of the wrong type of temp table. This could be a major decision, and you'll see where it was misused. Non-optimal index design. That's something that is a constant. Index design is not static. It's something that has to change with the type of volumes and searches that are constantly changing. We'll get through delayed filtering, access paths gone pretty crazy. Showed you some excessive story, and missing performance structures. I'm not going to go through MQTs, but just the basic, how do you build the perfect index for a particular query? Just what are those stages that you go through to build those? And then what can you do about stage 2 predicates frozen in SQL? That would be another performance structure. And just because we're limited on time, I don't have those particular slides, but that would put you in a function index, so that if you are doing math on a particular column, you can perform that math in its own particular structure to get matching index access. So we'll first start out with something you can all do at your own sites, is give yourself a report card. So here's an example of what I did for a particular company. I dove into their static, and it's the same, just count all these group bys, count the optimizes, count each one of these, just to get an idea how sophisticated they may or may not be. And this one was pretty sophisticated, right? They are doing some merges and truncates and intercepts, and but they're brand new version 9 dense, and they hadn't investigated into those yet. Yet when I ran the same queries on the dynamic side, noticed a huge difference. The different talent pool, and what that tells me is if they don't have the skill, they don't know what these clauses do, they're never going to end up in your production environment. So this is a good report card to actually put together to give yourself an idea. And what that means is you got to upskill, in order to get a tackle on your poor performance, because this lack of skill is going to be what is going to cost you lots of MIPS, which means a lot of money. Now, to get an idea of how sophisticated, this is just the sequence that I would rank the particular statements, and the goal is you want to get everyone into the advanced skill range who are working on your production systems, and to be a number 10, it really is code effective and efficient SQL, applying performance rules, and then the ability to know to use each of these clauses at the appropriate place, and not to misuse. And believe you me, you're going to end up today with the performance rules. We'll be walking through them, and I gave you them in a digestible format that you can copy them right out of this presentation and put them into your own intranet, and have your people coding your production systems have to go through each of those rules and make sure they're following those rules before they actually move it forward. So the first story I'll start with is this client called me in the middle of the summer and said, we need you like yesterday, Sheryl, because they had no sheriff. They basically had a very tiny DBA group, and they had just gone agile that summer, and which made a huge impact on them getting functionality out. But what it did is it overwhelmed the actual DBA staff, so that they could no longer be proactive in doing any proactive performance. All they were doing is really burning through heat tickets all day. So they said, Sheryl, come on board, and we're going to make you sysadmin. I went, excuse me, I've never been sysadmin before. Are you sure you want to do that? I go, yeah, and you're going to have access to everything, including production. Like, yikes. So the first story I have for what I found, and I was there on site, 5 days a week for about 7 months. And I got to know their development staff by eating lunch with them on a daily basis. And all of a sudden, I ran a count on the access to SysDummy1, and it was in the tens of thousands in executions. And it just popped up one day. And so when I went to lunch that day, I had to ask them as a group. I said, so some of you obviously have not been on a mainframe your whole life. Maybe you've come from other systems, and maybe those other systems, you have to check if they're up. And let me tell you, this mainframe has not gone down in decades. So you really don't need, before you insert, update, delete, you don't need to do a call to SysDummy1 to check and see if it's up. You just issue your update, and if it's not up, it will let you know. But chances are high that it's always up. So that was the first thing I had to do. I had to tell them, I'm the sheriff. I've got eyes on whatever you are coding, and when I see stuff that needs to be fixed, I'm going to be the first to let you know. So this was their poor situation. They were going to hit a $5 million upgrade, and see how rapidly they were moving up that summer. And so that arrow is where I came in. And the first thing I noticed when they gave me this, first report was they weren't looking at their dynamic queries. They hadn't even turned on the trace to actually do the explain on the dynamic statement cache. So the first thing I did was turn it on, let it run for a few days, and then lo and behold, up popped the most expensive statements. Well, one was the most expensive I've ever seen in my life, and then a pile more after that. So I immediately began creating indexes for this relatively new workload that obviously no one was providing the index structures. And that's why you see the great decline pretty quickly, because I had the right access. I was still afraid of creating the indexes in production. I threw them over to my DB8 because I didn't want to hurt anything. And he used to wait to the weekend, and then he found out how good I was and said, all right, Sheryl, whenever you come up with an index, I'm just throwing them out there. So it was very dynamic, and it just kept going and going and going. But here's the visual explain of the most expensive statement that I've ever seen. And at first, my first thought about how this statement came to be was some programmer was trying to impress their other programmers. And so they pulled all kinds of query blocks from other people and assembled them together. And it was highly repetitive. And notice, this access to this TB-bad address table. It was multiple times, and it was usually in a scan. And so I thought, well, we could certainly use an index on that for that query block. And so, yeah, there were some band-aids that I could put on this really quickly, but that really wasn't the problem. The problem was more about, well, let's look at the statistics on this. This statistics is in 3 days, 5,000 execs. And this is 3/4 of a million get pages. All right, so we're approaching a billion get pages. How many per execution? Well, you do that division, it's 628,000 get pages per execution. What business question could possibly need that many pages of DB2 data? So there the problem was. Let's find out what the purpose of this program was and what the actual business question they were trying to ask. And funny way to answer it is to access this table 4 times. And it turned out that it really wasn't asking for any data at all. It was simply hey, I want to know within this this date range, current date minus 90 days, if this person had at least one bad address. So it was really kind of an existence check. But since it needed data from two different tables, it wasn't the proper technique to answer this question was actually a join. And a non-exists is only when you need data from one table, but this one was from both tables. And so we got this execution down to, in two executions, 642 get pages, right? So imagine the savings. So the story I want to impose on you for this is different now. I view that previous statement as malicious. Someone put it together, and the reason it went undetected for so long is there was no purge criteria for that bad address table. They simply flipped bits. They flipped the flag. And so that table grew and grew and grew. It started out tiny and grew monstrous. And so this was a slow growing malicious MIPS nightmare. So something you've got to look out for, something you need to test for, and definitely keep checking in your dynamic statement cache for stuff like this. And it could pop up instead of slowly, it could pop up very fast. So something you need to keep your eye on, seriously. In today's world, there's a lot of internal malicious code that can happen. So they took their time. I've learned how to fix it, early in the summer, probably my second week. And they wouldn't put it in production until they had all their applications done. And that's because the way they were ranked. So here's another lesson learned. If your DBA team reports up into the application development vice president, guess what has precedence? Their development, not fixing anything. So they took their dear sweet time to fix it. And one day in September, they threw that new code in, and boom, immediately it dropped 300 MIPS. And then I continued to put more and more indexes in play. That brought the CPU down. And the other thing that I experienced is they had a very sophisticated test environment where they could, over a couple of weekends, really figure out the new code and roll it in very confidently through their QA process. And boy, was that a huge difference. When DB2 went in, I remember running my explain on my dynamic statement cache, and it used to hum around, and I had to do some purging of that over time. And I even had to throw some indexes on it because it got quite big. And the DBAs were laughing. They said, Cheryl, you had to put some indexes on your own queries? Yes, I did. But I ran that query as soon as it went, DB2 10, and it came back sub-second. So that just goes to show you what new technology, by keeping up your releases, and I see most of you are doing that. You already learned that lesson. You keep up, stuff goes much faster. So a few more that we've got to look at. Misuse of these types of statements, and they look very typical. It's going to cost you money. So let's go through some just basic rules. In general, joins over subqueries. And why would that be? Well, joins when detailed row information is required from multiple tables, and it may be the same table. Right? This is a self join. This is a student schedule class joined to a student schedule class, but we're looking at different rows. So this query is answering this business questions. What students have the same classes as any given student? So we're looking for same class ID, same time, but different student IDs. And so that means, yes, this is not going to be in a correlated exists or correlated in, which I hardly ever recommend. but an actual join is going to get me that particular answer. And then here's the rule for subqueries. When is subqueries over joins? When detailed row information is not required. And at this time, what students have at least one of the same classes as a given student. You know, we may have run that first query and gotten no one has the same schedule, all the same classes, but let's go for just at least one and see if we can get enough students to cover their entire curriculum. So, and this is correlated exists. I'm a big fan because your bottom subquery part is not returning any data. It's returning a true or false flag, which is very efficient. You basically correlate down by student ID, and where it's a different student, it's going to check, does it have at least one of the same classes? If it gets a true flag, that particular student goes into the result. And it'll go test all the students very efficiently. So I'm a big fan of correlated exists and not exists. Looking for the opposite too. And so here's one thing you got to disallow because these make no sense. If you put a join together, what is the rule about a join? You want data from both tables. What is this statement doing? It's only getting data from one table. And then it's using the keyword distinct, which never do, just never do. Whether it sorts or not, it's still a waste of time. So it's the wrong syntax for the job. We have another rule, and this does not apply to Linux, Unix, Windows, and it's an exception processing. To get an inner join, which is the intersection you're looking for, you know, where column 1 on X table equals column 1 on another table, that's that intersection point. But what if you want to just get the exceptions, the outer part, table X exceptions or table Y exceptions? Well, oops, there's two different ways to do that. One is this left join. And sometimes it's faster, but sometimes it's not. So here's when it's faster. When you do this left join, it can dive in and get those exceptions very quickly. But if those exceptions are that inner join part is huge, then this join syntax is much faster. So that's just a trick that only works on the Z platform. Another lesson, CRM application. They popped it in, and that's when they gave me a call, and they happened to be local, so I drove up about 20 minutes from my house, and they said, Sheryl, we've got this program. DBA, he said, I've been looking at it. I don't know how to make it any faster. It's our most expensive in this package. We really can't touch it, but can you help us? We just upgraded to a new Z9, and this one application is consuming 25% on a daily basis. So, wow, okay. What did it look like? Well, here's a picture of it. It had multiple processing through these created temp tables, and it was looping through. And the first thing it did is it did a select distinct from this giant set, and then it joined this giant set back through these other created temp tables, and another one and another one and another one. And so you're looping this giant set all the way through to get your result set. Well, we had to run it. We ran an experiment. I said, why is it a created temp table? Created temp tables can't have indexes. And if you're looping through something, you certainly would hope, especially if you're doing joins to it, that you're joining on an index structure. Here we weren't. So there was merge scan joins like crazy, tons of merge scan joins. And the merge scan joins are great if you want the complete answer to that join. But if you've got some heavy filtering going on, it's much too much effort. So, and it was deadline driven, and that's how those rapid application and development packages get put together. So they just, threw out the select CTT. When I changed it to a declared timetable, I put on a clustered index. Why? If you'd only have one index and you only needed one, make sure you make it clustered. That gives the optimizer a lot more information. It doesn't have to guess about anything. So it just really was, there was not a proper use of the temp table. And so here's the improvement. Smaller is better. Here was with the CTTs looping through merge scan joins, huge amount of seconds. With the DTTs, much less, right? Down to 15 seconds. So what did this do in terms of the average? Well, the average was 1.78 down to, and this is where you should be. You should be under a 0.1 second for your high volume OLTP, 0.07. That's where it should be. So the improvement was massive. And when we just for kicks, we threw out the executions and calculated that the savings for just changing this one program, and nothing else was changed, right? We just dropped the created and recreated the declared 2.8 CPU hours per business day. And what was funny is the DBA at the time, he pretended to call IBM and said, hey, IBM, that Z9 you just sent us, we'd like to return it because we don't need it anymore. We'll take our Z8 back, which is kind of funny. But that just goes to show you, the ripple effect of poor choice. So tremendous business value. So non-optimal index design. Well, why am I going to show you a bad example? Because I'm going to show you how to fix it. So here are the 4 points of filtering. Okay, the absolute best is indexable stage 1. And there's charts on that you can look up. It's 27, 31, I don't know what they're up to these days, of different conditions that can be used in the probe of your index, provided the columns that you're filtering on are in that index. So that's the big if. Second point of filtering, index screening. It's also called index filtering. It's still in the stage 1 category, meaning that same component has control. And then it passes control to the data pages. So the first point at the probe of the index, second point is through the screening, and I can show you that. Third point, I pick up the data page, and then the fourth point, which is this case in the where clause, that filter will take place. So what's wrong with this one? Well, the only item in my index is sequence number. Well, it turns out I got this lovely last name, which is a high filter, right? Depending on what the horse variable content is. But that could be pretty precise. That can't be filtered until the third point, which means I'm accessing in this index scan on the leaf pages a tremendous amount of data, where I then have to pull up all that data into the buffer pool, which really makes that buffer pool with a heavy footprint. And so I'm just showing you an execution where it's pulling up all that data, and it's got a heavy footprint. And so you gotta watch out for queries like that, and especially if they have to sort. So how do you fix it? Well, you add that last name to that index, and even if this has keeping you unique, you can add columns that don't that still maintain that uniqueness as an add-on. And now, since I moved it from the third point of filtering to this second point of filtering, I'm picking up way less data. And then I can throw that little bit of data, into the stage 2 processing for that little added filter toward the end. So that's how you fix it. You want as much knowledge in your filters to go into the indexes that you're processing. Another delayed filter case. This was this is students. Okay, so you got to put your brain in. The end users of this application are college students, and they're applying for money. And this was the application that they had to open up in a browser and click on. And when they clicked on this P-search, a lot of stuff was happening. The queries were designed to go get all the data from every cursor and bring all that data back into their browser session so that they can have this sorting agility. So you could sort it, by date, by amount, by how much time you can. I've got to let a cat out. Excuse me. Here, poor thing. Here, go. Sorry. She just likes to join when I'm talking. She assigned me, so that's why she does that. So anyway, it was based on the design that made this. Basically, now you're talking about, what if there's only 10 people looking for their loan information? Well, march that up to, you know how students are, they're always last minute. So now you've got, it's July and classes are starting in August, and this is when they said, Cheryl, we've got an emergency, you need to come up here. So here's how this thing was going. All tables were partitioned and clustered by sequence number. It went and got all that data. 9 services executed every time. And what do you think happens when the first student, opens a browser and it's taking some wall clock time? How many seconds do you think it takes a student, who's a little bit anxious that time in their life, to open up another browser? It's less than 3 seconds. Yes. So now they're making it worse. All right. Now they're opening, and do you think they stop at the second one? No, they're open third, fourth, fifth. They think something's wrong, and they think if they open a new browser, so this is where they were at. Here's the walkthrough, and it first did the last name like. Oh yeah, and I should turn this down a little bit because I got this pretty loud. It did a last name like search on an index, which was not clear, and that's why you see the arrows all over the place. So it had to go get those, and I put those sounds in for a reason, because you'll see when we get to the tuning part, see how much better it is. And then I had to go through another one to filter the whole code. Then I finally got to do the sequence number. And let me go back. And then it had to do a sort to get it in the right sequence, right, to fill their buffer, so that they can do some sequencing from there. So they had to completely build that whole scene. So here are the changes we made, and you can read through these, but instead let's just walk through it. And they're not significant. They're pretty easy. Recommending changes. It's even better just to add columns to an index than to create a whole new one, because then it doesn't impact your insert and delete activity. So these are easy changes. And it went from a 9.9 second CPUs. Yeah, think about that. 9.9 9, and that's not elapsed time, that's CPU. The elapsed time is even more than that. So yeah, they'd be hanging for 15 minutes. Down to 0.2 CPU seconds is where it needs to be. So now listen to those particular things. Oh, you didn't hear anything that first time. Why? Because it was index only. Right. So we put some stuff together here to make sure that that first access was index only. Second one only had to go through a tiny amount because we had a sequence range, which is a start and a stop along that roll code area. And then since we were coming out in guaranteed date sequence, there was no sort for the end of that. So that's how you went from 9.9 down to 0.2 seconds. So great lessons. And I kind of got the Purple Heart Award at that particular company for saving them, because they had very many angry students until I got there. So just to review, joins over subqueries when detailed row information is required from both sides. Subqueries over joins when you only need data from one side. Inner join over left join when exceptions are not expected or needed. Created global temp tables, 100% of the data is infrequently accessed. So yeah, you think I was anti-created? No, there's a reason for global temp tables. When you're just gonna do a scan, you need every single row. Don't bother putting index on it. And if you're only gonna scan it once, yeah, created is perfect. But definitely use declared with the clustering index when the DTT is large and the data is frequently accessed. We're looping through that, that's the rule. So these are a culmination of lots of rules. So what does it cost you? If you don't abide by these rules that I've already gone through, you don't want to delay filtering, you want to create optimal indexes, you don't want to have misuse, and you want to, upskill your people so that you take advantage of the powerful new features. So what I'm going to leave you with are these cut and paste areas. This comes from, of all Redbooks, an IBM Data Virtualization Manager for ZOS Redbook. And I did work for IBM for a couple of years, and I recognize most all of these particular rules. And I bless just about all of them, okay? And there used to be 23, now there's only 20. They did do some consolidation. There was a little redundancy when they first published these. And it's this particular table, if you want to look it up in that red book and grab the latest copy. It's pretty easy to cut and paste, and put them into your intranet so that people can walk through these one at a time. Do not code mathematics on columns and predicates. And the solution for that, if you're stuck with it, is that index on expression. Sort only the columns are needed. If you do order by EMPNO, don't include anything else. You do order by EMPNO, and you throw last name on there, which could be huge. You're extending, if you're going to have to sort for that, you're going to have an extra wide sort file. That'll cost you. Watch out for like predicates. If begins with is indexable, and if it's a contains is not indexable, and ends with is not indexable. That just makes sense. If you've got beginning characters, you're good. The stuff in the middle and stuff at the end, not very useful. Do not code not between. Rewrite as greater than a host variable or less than a host variable. That's more efficient. Now that could be changing in the near future. As you move into 13, this rule may go away, and that's why this stuff gets reduced over time. When I first got into DB2, I think there was 27 pages of performance rules, and now we've got 3. So this is a good deal. Use fetch first whenever possible. Keep your stats up to date. Code not exists over not in. Like I said, I'm not a big fan of ins. Exists as looking for your first hit or your first false, and not in is going to build a list, and you may not need that entire list. You may, build that whole list, and then the first one you're out, which means you needed a not exist, not a not in. This one, when joining 2 tables, put the larger table on the left side of the join. Now, this one I'll debate just a little bit, because it was my understanding, and again, I do deep dives into the SQL, that the join sequence in your from clause only mattered if you were above a 10 table join. So say you're joining 11 tables, then it makes sense really to put the tables in the most restrictive to the least restrictive sequence in your from clause, because that way, the optimizer just had a built-in limit that said, you know what, how many different types of access paths I can give you in an 11 table join? Well, let's at least limit it to, the first 100. And the first one I'm going to do, believe it or not, is a table scan on everything. Yeah, and then the second one I'm going to do is what you typed in. And then I'm going to do a random, execution sequences and see if I can beat either one of those. And so that's where that comes into play. Code where clauses with good indexes. Prioritize where clauses for their effectiveness. First code, the where clause that references index keys, right? So in your where clause, just like your from, like it's going to matter if you're over 11 table join. In your where clause, put your highly restrictive filters first, and the most restrictive in the very first, and then specially sequence them, so most restrictive to least restrictive, but in the order of your index columns. So first column of your index, you got 3 filters, put the most restrictive first, then down, all the way down. So, it doesn't matter. That's just good coding technique, and it encourages the optimizer for a more efficient optimization. Other good coding practices. When looking for a small set of records, try to avoid the full table. All case logic should have an else coded. Now, this is a quick fix. Go look up, do a query on all your cases, make sure there's an else in there. Otherwise, you get a null, and your programmer may not be testing for those nulls and may cause a hiccup. Another good rule, undo your nots if you possibly can. If you got a not in, and I use the alphabet all the time, and it's not in, these 23 letters of the alphabet. How about you flip that and code the 23 and make it an in? And so that's why the word if possible is there. If possible, what if it's 4,000 different values or 100,000 different values? Don't bother. Okay, so that it's okay to ignore this if it's not possible. Minimize the number of times your cursors are open and closed. Right? If you can use the withhold, it makes sense, and you've got an environment that allows for the withhold. I've worked at a client recently that had, get this, 0 people online at the same time as their batch processing. I know that's hard to imagine in a lot of your shops, but they could use the withhold like crazy. And it just depends on your application and your environment, and there may be a subsystem out there that's read-only, and you can get away with it. Rewrite any stage 2 conditions, and forfetch only on all read-only cursors. And let me give you the reason behind this. It encourages parallelism. So sometimes you need the whys in order to, enforce this, but that's the why. Encourages parallelism. Reduce the numbers of rows. Use subqueries. Basically, try to put everything in one statement if you possibly can. I've never seen ever a 5-table join split out into, even just a 2-table join and a 3-table join. That goes slower always. So put your stuff together. Block it out with subselects, or in your from clause. Try and keep your data types to match columns. Type the types and the lengths when joining. Otherwise, you've got some conversion that has to happen during the join process, which is expensive. And this one I laugh at. Limit the use of functions against large amounts of data. Well, if you need the sum of that big table, you're gonna throw the sum on that big table. That's the business requirement, and feel free to do stuff like that. And I can hear some of you laughing about that one too. Okay, the last couple ones. Do not code functions on columns. Now, first one said do not do math. This one is additional. Do not code functions on columns. Minimize the number of times your statements are sent through that DB2 engine. It's a good amount of instructions just to go to sys dummy 1. That could be 10,000 instructions just to go down into that engine, check sys dummy 1, has a value in there. So that's what we mean. Minimize your trips. And prune your select clauses. If you've got a where clause, it says where ampno equals this, where last name equals this, where everything equals this and this and this, those items are going to be equal that. And there's no reason for you to put them in the select clause. And where performance-wise, where does that impact you? Well, in the buffer pool, you got to peel all that stuff out, and that's energy that has to go through the engine and to peel all that stuff out. And it's not any new information because the only rows coming back are where all that stuff is equal. And then because this is a red book for virtualization, and they have an example in there using multi-level views to try and optimize your queries, which is basically another way of saying put everything you can into a single statement to get your business question answered instead of multi-stepping it in any other way. And so that brings me toward the end, and Martin, you haven't interrupted me. I'm hoping you've heard me through this whole thing, and I've not been talking to air. But my hope is, yes, I've hopefully increased your confidence in tuning queries and actually coding more efficient statements, not only for you, but your entire organization. So feel free to download this. I'm going to send it to Martin in PowerPoint, not a PDF, so you can scoop out, and I've got all kinds of really good notes in there. I spend just as much time on the slide as I do in the notes section for my research projects. So I thank you, and I say please share with all your friends so we can get, we want to take care of DB2 the best we can. While we're still, working at shops.
Alive. We're still alive.
Yes, while we're still alive, yeah.
Well, here it's.
All right, at this point, I'll take any questions.
Yeah, there is a question here for you from Perry.
Okay.
What software tools do you recommend to identify high CPU intensive SQL queries?
Anything that runs real time. I've worked for all the vendors, and the worst thing you do is have no tools. So do I have a preference at this moment? And again, I'm independent. Kyndryl, we take care of clients, and they make the choice. I don't make the choice for them. But I just saw a seminar, the beginning of it, of BMC's latest technology. And I'm here to tell you, they have won the most awards in the DB2 application development and tuning space. They have the most complete solution, and they now have a beautiful integration technique that allows you to look at your entire history. So if you've had BMC, history tables up for, a decade or 2 or 3, which is, if possible, it can look into all that history and detect patterns for you and graph them for you. It's pretty amazing. So, I'll leave it at that. But any tool is better than no tool. So, if you have IBM, check with IBM on their latest technology. If you got the Broadcom, they're always making improvements also, because they've got they stole a bunch of smart people from the IBM Silicon Valley lab, and so they're all very, very competitive. But great question, and no, I don't get any. I don't even own BMC stock. I don't get any royalties from that. But I just wanted to point that out, because that just came out recently, and I think that just puts them on the top for right now.
I was going to say I asked the question simply because I knew that you were in a situation where you were not. You could be objective on that. So
yes. Yes.
I left that as it is. Oh, and I'm not showing my screen. I'm showing you me building the replay. So let me go over here where I need.
Okay.
I was getting a head start. Sometimes I leave it until Tuesday, but today I'm working on it because, as I say, I've got a wedding tomorrow. My granddaughter's getting married, and then I'm on a plane on Sunday night over to the IBM lab in Germany. So I get my acting gear. So before we close, as always, I'd like to ask our final question we always like to ask, which is, did you learn anything today? And, we like to see that we're providing the value that people expect, and the answer here, I'll share that quickly, is 100%. Yay, we love that when that happens.
Yeah, and look at our timing. Our timing was pretty darn good.
Yeah, that's actually, you were right on the mark there. But there again, after the first 30 years are the hardest, aren't they?
Yes.
So with that, let me just put up our final page there, and thank you again very much for such a great job. I know that clearly people learned something. Thanks for the presentation, and I look forward to seeing you at an IDUG. I'm not sure if you're going to IDUG Europe. I'm not sure if I'm going there yet. But,
yeah, not Europe, but maybe Philadelphia.
Yeah, I decided to skip Philadelphia this year.
Yeah. But if you can believe it, they rejected this presentation, so I'm not a speaker.
I also had an old presentation reading, and there's my dog going off. Your cat was bothering you. It's really important here. So let me cue the music to cover up the dog.
Okay.
I think that sounds like that sounded like Lacey as opposed to Lily. There's 2 of them. But
There's 2 of them.
So here comes the music. Here comes the have a great weekend. Thanks again, Sheryl. And we'll see you in a couple of weeks for the next LUW DB2Night show. All the best, everyone. Take care. Bye-bye.
Thank you, everyone. Love y'all.